Good afternoon, everybody. I'm Pirjo Sanaksenaho, and my speech is about architecture as a combination of art and technology. The subtitle for the lecture could also be, How are the Egyptian pyramids connected to 3D printing? In this presentation, I will shortly run through the times and show some examples how Western architecture has always been connected to the technical inventions and new construction methods. I also look towards the future, how the architecture might look like when we'll use the new technological inventions. The example buildings which I have chosen to this presentation have been important for me somehow during my life. I have either visited them or they have impressed me through pictures and books. So this presentation can also be seen as a list of my 20 favorite buildings. Art, as well architecture, is a mirror of society and shows the spirit of the time. This Piet Mondrian's painting Composition 5 from 1914, exactly 100 years ago, tells us of the time when the art became non-figurative. Forms got inspired from the machinery and industrial society. Though it's a pure visual art piece, it has same elements as architecture: structure, rhythm, colors, texture. Architecture in its primitive function is providing humankind a shelter against weather and enemies. The first buildings were perhaps huts and caves in a rock. This picture of primitive hut is visualized by French theorist and architect Viollet-le-Duc in 19th century. The huts of children on the right, they are familiar to the primitive architecture, branches of a tree modeling the walls and a roof like a tent. The experiencing of a space, the basic element of architecture, is existing already in the early primitive huts. The need for a human to create shelter and space, get a foothold in time and space, is in the core of architecture. Just the methods, construction systems, and the reflecting society is changing. In Egyptian architecture, huge structures were built in stone. They were built layer by layer. The massive stones were lifted above each other by a large number of slaves and with the help of ramps. The powerful government and vast labor forces made it possible to build huge monumental buildings, which were the tallest man-made structures on Earth until the 19th century. Here are the Pyramid of Khafre at Giza and stepped Pyramid of Saqqara. I have taken these pictures in 1989 when I was in Egypt with my student mates as an architecture student. In ancient Greece, the columns and the beams were the simple basic structural system in architecture, without vaults or arches. The Greek temples made of stone still do survive, though the common buildings made of mud, brick or timber have disappeared. In this picture, there is a Doric temple in Segesta from the 5th century before Christ. The concrete was new invention in ancient Rome. Pantheon, which was built on time of Hadrianus in 118 to 128, is the finest existing example of that. The breakthrough was the development of lime mortar, in Finnish kalkkilasti, where they added volcanic ash. It was cheap material and easy to produce. First, it was used in aqueducts and docks, but then they realized it was good material to create monumental interior spaces. Roman concrete was called opus cementicum. The skylight above the round space makes the interior of the Pantheon one of the most powerful in Rome. The bricks were reinvented in the Middle Ages, though they have been used for thousands of years. The brick walls made it possible to make windows also between the walls. Turku Cathedral is the only basilica church in Finland where the middle nave is higher than the side naves. The building has been important for me. I have lived 18 years, just a couple of hundred of meters from it. The major breakthrough in Baroque period was a building technology was the manufacture of glass. The first cast plate glass being developed in France. The meaning of natural light became more and more important in religious buildings. This is Francesco Borromini's San Carlo alle Quattro Fontane, built in 1667. In the 19th century, steel was mass-produced, so it was used in I-beams and in reinforced concrete. Glass plates also went into mass production and changed from luxury to everyman's property. The Crystal Palace was a cast iron and plate glass building originally built in Hyde Park, London, to house the Great Exhibition of 1851. The Palm House in Kew Gardens was as well a masterpiece of the engineering. The Industrial Revolution was manifested in transportation installations like bridges, canals, railways. With the second Industrial Revolution in the early 20th century, elevators and cranes made it possible to build high-rise buildings. New York is the manifestation of new high-rise architecture. The towers and skyscrapers are again very up-to-date, especially in the Middle East and Asia in the growing new cities. I took this house as an example of cantilever structure and reinforced concrete houses of 20th century. Frank Lloyd Wright's Kaufman House, called also Falling Water House, in Pennsylvania, shows how the spirit of the space and art of construction can make unique experience for several senses. The sound of the waterfall and the low human scale could be experienced only at the place in reality. Modernistic architecture trusted in steel frame construction with glass walls. Mies van der Rohe's Neue Nationalgalerie Art Museum in Berlin was built in 1968, and it is one of the most powerful architectural experiences I ever have had. The roof is standing only on 4 columns, and the light glass walls make the interior area spacious. Even the human figures who are walking in this space start to look like art pieces. In Finland, this modernistic frame structure with glass walls got domestic features with wood. In Otaniemi Chapel, Heikki and Kaija Sirén made the nature to become part of the church interior with big glass walls, and the construction was timber. In the 60s, the concrete brutalisms got also very delicate solutions. One of my favorite buildings in my childhood was the Civilize Museum in Turku, which was designed by architect Voldemar Beckman. The sculpture's concrete columns made the concert hall intensive atmosphere. The surroundings with historic buildings shows how each building can speak the language of its own time, and they still fit well together. Another example of concrete architecture of 60s, ceiling of Kaleva Church in Tampere by Raili and Reima Pietilä. Concrete cast on site made it possible to do expressive forms, as we can see also here in Dipoli, by the same architects. Now it's, sorry. Computer-aided design in the late 20th century made it possible to design organic and expressive forms in architecture. Frank Gehry's office was the pioneer in using new CAD programs. They used the same programs as NASA. This building, Bilbao Guggenheim Museum, is a good example how contemporary architecture is reflecting its time and giving value to the city when cities are competing with attractions. In my opinion, Helsinki shouldn't lose the possibility to get high-level architecture and attractive public building to the city, but Helsinki Guggenheim shouldn't look like this, but something that has not yet been seen anywhere. The contemporary architecture doesn't need to shout with effects, it can also speak quietly. Built over the thermal springs in Swiss mountains, this hotel and spa designed by Peter Zumthor shows how the cave architecture can be reinterpreted in our time. Local stone became the driving inspiration for the design. Another example of impressive silent architecture by Peter Zumthor, where the tectonic idea is as powerful as in primitive architecture to create shelter. This is St. Benedict Chapel on Alps. In the picture on the left, there are my two oldest kids, 13 years ago. Then one of our own projects, St. Henry's Ecumenical Art Chapel in Turku. In this chapel, we wanted to use simple and primitive ways to create architecture. The building is made like an upturned wooden boat. The curves of glue-laminated timber are equal, they are cut just in different heights. The idea is to work towards the light, which source is hidden. Recent technology expands the possibility of timber to be used in large-scale architecture. The timber is ecological and sustainable material. The giant timber canopy is built over a plaza in Seville, Spain. Prefabrication, CNC machinery, structural modeling, and industrial robots make it possible to make even larger timber constructions. Also, many new timber materials have appeared. The new way to design buildings is to use algorithms in design process. The scripts given for computers may guide the designing towards the most reasonable solution. In the picture, there is a wooden structure designed with the help of algorithms in Oulu University by Eero Lundén and Toni Österlund. The architecture of the Museum of the History of Polish Jews in Warsaw, which was opened for public last year, is designed also with the help of algorithms. And it's a good example how Finnish architecture can be exported abroad as well. We are on the edge of a revolution in building technology. The 3D production will do it possible to make all the building units unique and different with low cost. The 3D printing is happening layer by layer, as the ancient pyramids were built stone layer by stone layer. We won't anymore be forced to use mass serial products in construction. It makes huge freedom for architecture. I suppose that more organic forms will be used. Here's a picture about the robotized building process of a one-family house. Italian engineer Enrico Dini has developed a huge three-dimensional printers that can print entire buildings out of sand and inorganic binder. The printer can create a building 4 times faster than it could be built by conventional means, and reduces the cost to half or less. This is 2-meter-high sculpture, and it took 10 days to print it. Layer by layer, the final one is 8 meters high, and it's situated in Italy. Architect Sir Norman Foster is developing, together with European Space Agency, how the moon could be colonized with buildings that have been printed out of lunar soil. It solves the cost and logistics of transporting building materials from Earth through the space to a location hundreds of thousands of miles away. On the other hand, if almost anything is possible, with a new building technology, we might search for harmony and rules anyway. Maybe in the vertical and horizontal lines in architecture, it is more question of gravity and horizontality of the land or the sea than building techniques. The basic needs of good human environment won't change through the times. The shelter, natural light, sustainable materials, connection to the nature, and a scale that is related to the scale of a human being will stay, whatever the architecture will look like. The same striving towards the effect of natural light can be seen in Hagia Sophia, built 1,500 years ago in Istanbul, on the left side of the picture, and very recent picture project by Japanese young architect So Fujimoto, an outlook tower in Qatar, which is not yet realized. The students are usually in the forefront of new architecture. The new inventions have often been made in universities. As a professor, I have a viewpoint to the new ideas and inventions in architecture. This Elina Proterus photograph shows my feelings at the moment as a new professor of building design in front of great views for the future, which our multidisciplinary university makes possible. Thank you.